Hi everybody, welcome to this first chapter. We are going to talk about sensor networks. As you see, you have the sales department email and the Libelium website. In this slide, you can see the index we are going to follow. In first place, I'm going to explain what a sensor network is. In second place, we are going to see the different sensor network elements, for example, the nodes and the data gateway. And finally, we are going to see how to communicate this data and how to monitor this information. So, what is a sensor network? It is a deployment of several devices equipped with sensors that perform a collaborative measurement process. This way, we can choose any kind of sensor to be used for a specific purpose. For example, logistics, smart agriculture, smart environment, industrial control, and many others. Here you have the working process of a sensor network. We have three parts. In first place, we can send any kind of value measured from a sensor. In second place, we can use any kind of protocol to communicate this information. And finally, we have the external system in order to show this data. Wireless sensor networks introduces us a new concept in our lives, which is smart cities. A smart city will permit us to know several important values like the city pollution, noisy points, networks. For example, quality of shipment conditions, structural health monitoring, animal farm conditions care, wine quality enhancing, forest fire detection, air pollution and radiation levels, smartphone detection, traffic congestion, intelligent and adaptive streetlight management, electromagnetic level monitoring, definitely endless possibilities. Now, I show you the different elements within a wireless sensor network. Firstly, you see the node. This is an autonomous device equipped with sensors. Secondly, you see the data gatherer. This must be a data capturer device, and also it should be connected to external systems in order to transmit the sensor values. Finally, the third element is the external system, which should be a data storing and management center. Libelium provides both node and data gatherer. The Wasmode device structure is composed of a microcontroller, several sensors, a battery, communication modules, and some kind of a storing system, for example an SD card. In the case of Wasmode, we have a modular architecture, so we can add or remove modules depending on the goal we want to achieve. In this slide, I show you the device's power management. We have three low power consumption states so as to have more battery life. But how does it wake up? We have two different methods. The first one is a timeout, and the second one is an interruption provoked by sensors. Wasmode permits to use two communication modules at the same time. In first place, you can see the XBee modules, 802, Zigbee and Digimesh protocols. In second place, you can see the Bluetooth modules. In third place, the GPRS or the 3G modules. And finally, we have the Wi-Fi modules. In the case we want to store some data, we can use a non-volatile memory with some available space, or maybe we can use the SD card to store all the sensor values. In this chapter, I'm going to explain you the data gatherer. In other words, the measuring device. Basically, it's a multi-protocol router with several interfaces on it. 802.15.4 or Zigbee protocols, Wi-Fi, GPRS, Bluetooth, or GPS protocols. Besides, Meslium provides an application called Manager System that permits to configure Meslium very easily. In this video we can see how we enter inside Manager System. So we see different labels related to interfaces, sensor networks, tools, system, update manager and help. Inside interfaces we can select the Ethernet label. Here we can choose between static and dynamic IP addresses. Inside the DHCP protocol we can show all the information related to the IP address, the DNS address, and so on. Now we go through the Wi-Fi access point label. Here we can set up the AP settings, for example the IP address, the net mask, and so on. Besides, we have other settings like the ESSID, the channel, the protocol, or the transmission power. And last but not least, we have the security option. As you see, we can select between known WEP or WPA options. Now we go to the Sensor Networks label. Here we are able to configure the XBee module within the Meslium device. So we can choose the network ID, the channel, the network address, the node ID, the power level, encryption mode, and the encryption key. Also, we can check the MAC address of this XBee module. And if we press the Check Status button, we will be able to check the actual parameters that are configured in this XBee module. If we enter the capturer label, we will be able to see the database of this machine, where all the XBee frames are stored. Now we go through the Tools label, where we can see different applications. For example, we can calculate the Fresnel parameters, or we have the iPerf or ping applications in order to check the connectivity to other machines. As you see, we enter the IP address we want to test, and then we have the results. We have other applications, for example the Wi-Fi scanner or the Bluetooth scanner, that will permit us to scan devices that use this kind of protocols. Besides, we have this PHP MyAdmin Manager in order to access to the database in this Meslium device. This way we can get all the information that is important to us. In the system label we can choose the hostname of our machine. Also we can select the password of this Meslium device. In third place we have the disk usage of the machine. Also we have the temperature sensors. And finally we can set up the time of this machine. Now we enter a new chapter related to data communication and monitoring. We have two options: a direct connection from Wasmod to networks, or use a Meslium to store data and to synchronize this data to external systems. So one option is to use a GPRS or 3G module in order to communicate the information to the base stations of the telephone company operator. On the other hand, we can use the Wi-Fi modules in order to communicate the information to an access point, or in other words, a router. As I said before, the Manager System permits to manage the database in the Meslium device. If we go back to the capturer label, we can see how to manage this. We can see the database name, the table name, the IP address, the port, the user, and the password. We are able to save the data received in this Meslium, and also we can choose the number of insertions we want to show on the screen. This way we can see the different sensor frames stored in this Meslium. The first column is related to the ID of these insertions. The second column refers to the date of the insertion. The third column refers to the synchronization status. The fourth column is the WAS mode ID. The fifth column is the serial ID of these WAS modes. The next column is the frame type, and then we have the sequence number and also the sensor and the value. As you see, we have different labels for each sensor. In this case, we have a battery label, a accelerometer label, a time label, and a string label, and so on. Now we are going to see how to synchronize the data inside our Meslium with an external system. As you see, I am opening a new manager system related to another Meslium. So in conclusion, we are going to synchronize both Mesliums. Now I go inside my local database and I show 100 insertions. As you see, in the synchronization column there are some frames that need to be synchronized with the external device. Now I go to the external database label, where I can set up the external database name, the external table name, the external IP, the port, the user and the password. If I switch the tab, I can see my external Meslium. If I look at my local database label, I can see the settings of the database. Then I go back to my original Meslium and I can see how in the external database label my settings are correct. Then I check the connection with this external device. Also, I can set up the synchronization period I want to use for my synchronizations in an automatic mode, in this case 30 seconds. When I press Show Data button, I can see all the synchronized frames in my external database. As you see, the timestamp of the last synchronized frame is the same as I can see in my local database. So now, if I want to synchronize both Mesliums, I go to my external database label and I press the Synchronize Now button. After a few seconds, both databases have been synchronized. So I can press the Show Data button in order to see the new synchronized frames. This way, new frames have appeared on the screen with a new sequence number and a new timestamp. If I go to my local database label and I press the Show Data button, I can see how these frames have been synchronized, and the synchronization column indicates so. Then I go back to my external Meslium and I can check how these new frames have been inserted too, just comparing the new timestamps.